A really warm welcome for this afternoon session on case studies. My name is Calvin. I gotta get a little bit profile on myself. I am from Brixis, part of Hexagon, and then today I will be your host, or rather your MC. So we're gonna kickstart this awesome session with the topic of openBIM and GIS beyond visualization. Very fortunate to have Astri, a global leader in the GIS technology, to be the forefront of bridging these two particular components together. And very fortunate as well to have Daniel, who is the Senior Solution Engineer. Please correct me if I say wrongly, AEC APAC, and as well as Rodney Chin, Product Engineer at Astri, who plays a key role in developing innovative GIS application. With this, together, they will take us through how openBIM and GIS transform the way we design, build, and manage infrastructure. Let us welcome both gentlemen from Astri.
Hi, everyone. My name is Daniel Chantlos. I'm a senior engineer a solution engineer for Esri, our APAC office here in Singapore. I've been with Esri for about 5 years. Before joining Esri, I was leading a GIS team for a civil engineering firm back in the US. But I've been involved with a lot of 3D data within the AEC space, and it's grown a long way over these past couple years. So today we're going to walk through a couple examples of how openBIM and GIS integrate and work together beyond the visualization aspect. So we've specialized the visualization of BIM data in a GIS environment for several years now, but now we're moving on past that and introducing more analytics, more actual use cases and reasons why we should see more BIM and GIS integration. So we'll first start with the ArcGIS 3D system of record that Rodney here will introduce, and then we'll move on to some actual use cases. I think you'll all be pretty excited once we see them. So I'll hand it off to Rodney.
Thank you. Appreciate that. Hello, how's everyone doing today? All right, you guys can hear me okay? All right, so thank you for that introduction, Daniel. So as he said, my name is Rodney. I'm a product engineer at Esri. And so I want to talk to you a little bit about the 3D system of records. So what exactly is that? So we like to define it as a system that stores and manages 3D digital content and data. So essentially, we leverage the strengths of the ArcGIS platform so you can store your 3D content in a system that can be utilized later across projects. So let's give you an example. So right here, we have the city of Zurich. And as you can see, there's already a bunch of different layers of data that's already on the screen. We'll start off with the 3D base map in the background for your generic buildings, right? We had some bathymetry data there. And right now we're gonna add some vegetation just to kind of give it a little bit more an organic feel. So to get a little bit more in depth, we're gonna add a reality capture in here to give it some, so a little bit more context. But that's still a little bit more on the generic side. So what we're gonna do is we're gonna focus a little bit more on our area of interest, right? So we're going to zoom in onto our rail station here. And as you can see, the rail station is a lot more in-depth and a lot more detailed compared to the environment. So all of this is done in what we call a scene layer. So what the scene layer does is it assembles all of your different data, optimizes it, and helps you share it to the web. So that way it's easily shareable amongst all of your different stakeholders. All right, so continuing on with the Zurich example, we have VBZ. Now VBZ is they're a public transport operator that's based in Zurich, and they're working with an infrastructure digital twin. VBZ visualizes above and below ground construction in the same scene viewer, so that way it saves time and minimizes any sort of disruption. talking a little bit more about the 3D system of records, we basically break it down into four sections, four main sections. So, or what we call pillars. So starting off, we've got your data management. That's where you're going to be storing and storing all of your digital data there. And then we've got your analysis. So with your analysis, we leverage all of the geoprocessing tools from the ArcGIS platform, which is literally thousands of geoprocessing tools to allow you to do various different types of analysis that you might need to do with your data. From there, how are we going to visualize that? What is the best way to bring that information across? We give you many different options, from 2D to even more advanced things like animation. And then lastly, we have your immersive experience. What is your final product going to be? Is it going to be something like a 2D layout, a print, or something like that? Or perhaps it's going to be something in a game engine. Depends on what your needs are. So right now we're working with the different layer types, right? So here's where your data is. You've got your elevation data, so that's going to be your DEMS, things like that, your imagery also included, as well as all your different feature types. Maybe that's polygons, maybe that is 3D models, maybe that's linears. Depends on what you have and what you need to do with. All of those are combined into your scene layer, like I said before, which is optimized for displaying a lot of your information on the web very easily. All right, so we also have the ability to import and export 3D models that were created outside of the ArcGIS Pro platform. So the file types are kind of listed in the corner, but I'm just going to name a couple. So you got your GLTF formats, which are widely used in your game engines, so like Unreal and Unity, and also IFC, most notably the 4x3. We also give you access to a bunch of interactive analysis tools. And the entry point to getting in here is very easy. So it's a low entry point, it is a low entry point and a low learning curve. So for example, you've got your shadow analysis, dimension annotation, line of sight, and dynamic weather, just to name a few. Continuing with the 3D, with the analysis tools, we've got our viewshed analysis. So what this does is it gives you a better understanding of viewing all the different angles based on user input. What can be seen, what cannot be seen. And then when you have your web scene viewer, it brings all of the advanced geoprocessing tools from our desktop platform to the web for ease of use. And with that, I'm going to leave it here, and I'm going to hand it back to you, Daniel.
Good job. All right, so now we've actually established what this 3D system of record looks like and how it operates, but let's actually go ahead and take a deep dive and see some real great use cases. So first and foremost, this comes out of our Hong Kong distributor. This is called the Smart Site Safety System. And what this involves is BIM and GIS integration, as well as real-time IoT integration. This is actually mandated by Hong Kong CIC for any construction project over 30 million Hong Kong dollars. And it's mostly for worker safety. But this is also great for project supervisors, because for many of these projects in Hong Kong that are modular construction, most of the operations happen off of the job site. So this single application that's running in ArcGIS Experience Builder brings together and connects together all of these different types of data components for a full supervision system. We've got real-time IoT, we've got BIM model integration into the scene viewer, and we've also got digital work submission system that allows you to see all of the submitted surveys and inspections from the job site itself. This also comes from Gammon Construction out of Hong Kong as part of their Smart Site Safety System, and this is CCTV integration. So what we have here is the IFC model that's been uploaded and hosted on ArcGIS, as well as the XYZ locations of the actual CCTV cameras. So by using that IFC model as that base foundation point of understanding where the construction is ongoing, we can have supervisors anywhere view exactly what's going on with the project at any given time. This is a really great example. Now, this is in Zurich, and this is more of a story. What we're looking at here is a superimposed photo of a real flood that happened in Zurich, and we're using the flood impact analysis solution on a 3D base map to understand what sorts of buildings would be affected. In this case, we're looking at the train station. We don't want that to be affected, but what if we brought in an underground tunnel that would funnel water that would half the amount of volume from this uptake in the stream and then bring it into the reservoir that's dammed off before it gets to the city. So what we're able to do is bring in the BIM model directly into the scene viewer, and using some of our interactive analysis tools, we're able to slice that BIM model open and see exactly, share with our stakeholders and the public exactly how that underground tunnel is going to interact and take that water from the stream and dump it into the reservoir from the intake to the outfall. So that's what we're able to do here with our JavaScript API. Now for another industry, we're looking at the commercial aspect. So this is using our game engine SDK for Unreal. So this building is hosted as a building scene layer, I3S layer. And what we're doing is actually using the game engine to not only visualize and render this commercial building in the Middle East, what we're able to do is then use some of our sunlight and shadow analysis to help them price their units and share that with prospective buyers of these different units. So it's a little bit of a different use case. Now this example doesn't quite involve IFC data, but it could. There could be IFC models. But what we're looking at in this example is a traffic management simulation on a construction site. So this is taking the reality capture data that was captured from a drone of the current conditions of construction, and then we're using the civil design data to create 3D objects direct into the game engine, and then simulating what that traffic management would look like. This is something that's mandated by a lot of different construction agencies around the world. There just hasn't really been a great way of showing this until a solution like this comes around. I thought this was very interesting out of McConnell Dow from Australia. Now, there's another way to render the game engine, and we call that pixel streaming. So by leveraging a remote server to render your game engine, you can actually use a game engine application on the web. So in this example here, we're looking at a bridge structure that is a building scene layer package. I believe this is a Revit model, yes. And it was created using the game engine, and we get those really great animations. We also get the really great daytime and nighttime visualizations that you would only really see from a game engine. What's really great about this is now we can go into first person point of view and actually drive down that bridge with the lights illuminating, so we can make sure as civil designers and share with the public that this design is safe and sound. Speaking of which, we also have this X-ray mode that you can then visualize all the different stress points on that structure itself. So this is really great. This comes out of our Norway distributor geodata. Now that's really great for all the hosted data, but what about wind flow analysis? Here in Singapore, if you have heard anything about URA, URA really likes to design with wind in mind to try to cool down the island. It's very hot here. So what we can do is we actually have this third-party partner called Airflow Analyst out of Japan, and they use computational fluid dynamics to create these wind flow scenarios. So if we had hosted IFC models for different scenarios, we could make sure that we are either creating positive wind flow corridors and not impacting existing wind flow corridors. This all happens in the ArcGIS Pro application. In this case, we're using a reality mesh, but it could be IFC. Now, this one's really interesting as well. Think about the tree roots in cities and underground facilities such as utilities and building footprints. Those tree roots will just continue to grow and eventually impact existing structures, causing huge maintenance scenarios. But what we could do is actually bring in that sort of tree root crown, if you will, and we can use our time slider tools to visualize and properly estimate when those tree roots may impact existing facilities. So that's exactly what we're doing in this scenario out of our Zurich digital twin. Now, what about buildings in operation? So this here is an IFC model that is in ArcGIS Pro. We're not in the web right now, but we've connected it to a graph database using ArcGIS knowledge. So for example, when a window needs to be replaced, we can submit an alert, and then we can open up the graph database to see who the installer was, when it was installed, who to contact for a new one to get it delivered and replaced. This helps streamline all of those sort of third parties that would be involved in a scenario like this. It might not just be windows, it could be any part of your building and operations. There could be water leaks and so forth. Speaking of facility management, we can also connect our BIM data, in this case the MEP model, direct to business system integration, such as ServiceNow in this case, or SAP, for example. What that involves is actually connecting the business system to the 3D rendering so that you can edit in one system and see those edits show up in the 3D environment, host that through dashboards, and then you can show that floor by floor or however you want to visualize it. It's really about bringing more information to you at a quicker and more efficient way. And then for the last example here, we actually have a really good partner out of New Zealand called Reveal. I think any construction project cannot happen unless you understand the utilities underneath the project itself. They specialize in taking as-built data and ground penetrating radar and corroborating that into a full 3D accurate model where they are using ArcGIS as the 3D system of record to host all of this information. In fact, right now they're working on getting the entire continent of Australia within ArcGIS into a single scene. So it's quite impressive what they've been able to do. But I think that more or less sums up how you can bring in your 3D and BIM content, IFC models directly into the scene viewer. And for all the tech people in the room, you can take a quick screenshot. This is exactly how you would bring your IFC models or your Revit or Civil 3D direct into the ArcGIS environment. The end goal is to get to that building scene layer package, I3S. You may also think of 3D tiles, which we can also render as well. So depending on which format you're working with, I think it's quite useful to understand this small little workflow that can be automated. So just to basically summarize everything we've talked today about, the ArcGIS 3D system of record is a way of managing, storing, analyzing, visualizing, and creating those immersive experiences. Now we also have the ability to be open and interoperable as a data exchange with many different data components and file types, including IFC. And then also the advanced 3D visualization and analysis for digital twins. This is really about giving you more contextual intelligence. This is where GIS shines, adding that extra bit of context to your project that you may not see in your design applications. And then lastly, spatial analysis for insights. This helps you make decisions based on the location of which your projects exist and what may impact your project. So thank you again for listening today, and I'll hand it off to the next speaker.
Thank you, Daniel. Thank you, Rodney. All right. Off to the next sub-track. As the construction industry converge and embrace in digital transformation, Canada is actually taking a significant step towards this particular development of the digital construction platform led by the NRC, which is predominantly the National Research Council of Canada. This initiative aims to enhance, collaborate, streamline, process, and drive innovation through an open environment. And today, we actually have the privilege of hearing from two experts who is deeply involved in this particular initiative. We have Erik Poirier, Board of Directors member at buildingSMART Canada, and Farzad, if I pronounce it correctly, Farzad Jalaei, Research Officer, Digital Construction Solution Lead at NRC itself. Over to you, please.
My name is Farzad Jalaei. I'm the Research Officer at National Research Council of Canada and Digital Construction Processes Lead. So we are part of the federal government of Canada and acting as the research and development arm of the federal government. So part of our plan is to kind of like adopt the openBIM language and creating such kind of like a common data environment, first like starting at the federal government level, collaborating with the other government departments, and also hand it over to the provinces, territories, municipalities level, and the project level. So that's why this report that is recently published, it's in collaboration between National Research Council Canada and buildingSMART Canada chapter that is kind of like we have two versions of it, and it's available at the buildingSMART Canada's website. That's called Digital Construction Platform and the Digitalization of National Construction Codes and the Development of National Common Data Framework. We have the full report, which is around like 150 pages. And we have also the summary of this as the executive summary that is like conveying the summary message of this report. The comprehensive team actually worked on this. Erik, my colleague, is here. His research team at École de Technologie Supérieure, sorry for my French language. So the university, actually the research team worked on it. It also like include the NRC team and the government also officials from Department of National Defense, Public Services and Procurement Canada, and also some experts from the Ministry of Housing at the province of British Columbia as the early adopters that they were participated in this. I'm telling some stories behind the platform that we have started at NRC, and Erik will continue the details about what is inside the report. It's actually part of the platform to decarbonize construction sector at scale. For those who attended the Montreal buildingSMART International Summit, I introduced this platform in year 2022 for the first time, as this was one of the federal government investment to kind of like help the federal government in achieve its targets in reducing the carbon by 40% until year 2030 and moving toward the net zero commitment by year 2050. That was kind of around like $192 million investment to help industry, specifically SMEs, to decarbonize and also enhance the productivity. Since we witnessed the productivity improvement in Canada was almost less than 5% during past 2 decades. So this platform distributed in 3 main trusts, as you can see here. The first one actually is the receptor of this platform. And this report actually is like directly part of this trust, is called Low Carbon Regulatory Framework. It includes kind of like transforming the current codes that we own at the national level, National Building Code, Fire Safety Code, that you may heard some presentation about our National Fire Safety Code and the IDSs that recently developed. Yesterday, my colleague Yoon actually presented on that. Digitalizing the code and making it machine readable, as well as the national master specifications are also like part of this platform. 2 programs, R&D programs are in parallel working to report back to the regulatory framework. One is about the decarbonization, that's called low carbon built environment, and they are mainly focusing on life cycle environmental impact assessment and how to create the Canadian specific data, facility specific data, working with the decision support systems, and conducting the life cycle assessment in the whole asset level for building and infrastructure. And the program that I'm basically into that is called Construction Sector Digitalization and Productivity. We are focusing mainly in terms of bringing in the digital construction solutions as well as advanced construction practices to enhance the productivity and help the other programs and specifically the regulatory framework in terms of digitizing the rule sets and creating such common data environment at the national level. The projects that so far we have started and we are working on it are basically categorized in three main categories or master projects. One is about creating the guidelines, adopting the existing standards or creating the new standards, and also like working on creating so many modules under this common data framework or common data environment as enablers or as kind of like applications. And the third one is just showcasing the demonstration projects. I call it kind of like a IKEA analogy. So we providing the manuals, we providing the tools to build and customize for your case. And we have a showroom as the success stories to just show how this kind of like different pieces are attached together and what is the business value of it and valorization framework, I mean, to industry, to kind of like a showcase that this has the value to move to that direction. And this is the manual, how to do it. And this is the tool or applications to use it and customize it for your own purposes. We identified 10 main R&D areas that like it started from circular economy, life cycle environmental impact assessment. The report is available on NRC website to be explored. And the report that today we are presenting is hitting one of those streams about the digitalizing the code and specification. And last year, actually, in Valencia, we showcase the openBIM roadmap that we published. It is still one of the good examples of like how to explore the success stories in different parts of the world and what is the Canadian construction status in terms of adopting the openBIM. And we also showed one of those piece of puzzles in terms of using openBIM integrated with life cycle environmental impact assessment and the IDSs that we developed for embodied and operational carbon and the NRC openBIM LCA application, how to like take the data in standard way, process the data, visualize the carbon number, and how we can use it for the benchmarking purposes. Here, the main target for this digital construction platform is how to create different scenarios for national model codes, since we have the codes, National Building Code, Fire Safety Code, plumbing code, and also energy code. So how we can create this digital construction platform to host the digitized version of the codes and like moving toward the code compliancy checks and probably later on for the permitting purposes. We also own national master specification. It is kind of adopted from the OmniClass uniformat and master format, but it's customized for Canadian construction industry. And we are using it as our design and construction specifications that that has the standard specification, naming and numbering nomenclature. And we also own the Canadian Construction Materials Center, who is certifying and evaluating the materials and products, almost like they are working with over 6,000 entities in Canada, to evaluate their products and to certify it, and to the evaluation goes against the national level codes. So all this stuff, like how it is going to be represented in the digital construction platform, how it is going to be communicated in the standard way with the other government departments, and then with the industry, is something that we will explore in this presentation, and it's also like reflected in the report. I hand it over to Erik to speak a bit about like this project. Yeah, thanks so much.
All right, thanks, Farzad. You'll be back, so you can he can applaud. You'll come back. Don't worry. Thanks. So yeah, this was a fun project to work on. It's not every day that you get. We've been asking for a government. I'm an academic, and construction, at least in Canada, is undercapitalized. There's low R&D spending, and now one day we wake up and there's a $197 million project that aims to decarbonize the construction industry in Canada and increase the productivity. So this is opportunity of lifetime to actually influence. Just for the people in the room, the Canadian construction industry is very, well, like everywhere else, fragmented. But you have to understand that Canada is a confederation, 10 provinces, 3 territories, 5,000 municipalities across the country. We have one national master construction code, but each province regulates their own construction industry. And then each municipality regulates their territory, so bylaws, and some provinces have their own construction codes. Some provinces use a national master construction code. Most architects use the national master specifications that are offered by the NRC, but they tweak them a bit. So we end up with this very fragmented and expanded information specification material landscape in Canada. So we set out to create basically the architecture for this digital construction platform. What is this digital construction platform going to do? So the first objective, is to define what this is. What does this look like? NRC is not an asset owner. It's basically the research and development arm for the Canadian government, but it has very important levers that we saw here. It will set the tone for regulation around the construction codes, what can be built. It'll then what can be specified, or how we specify materials and products, and then actually certify the materials. So you have the 3 ingredients here. If you want to promote digitalization in the construction industry, these are the 3 key materials. And we're seeing around the world with the Czech Accord, and in Europe, in Singapore, of course, we've been following the work in Singapore for a long time around, if you want to get people to move towards digital construction, digitalization, you have to use your regulatory levers. So this was an opportunity. So here are the objectives, essentially sustainability, productivity, decision-making, regulatory compliance. I think these are things that everybody in this room knows. So what does it look like? It can't be a monolithic thing. Again, NRC is not a building asset owner, is not a tech company, doesn't develop technology. It does have some certain plugins and does some cool work, like Farzad was saying with the openLCA and so forth. So it'll create specific tool sets, but it will not develop and host a platform for the entire construction industry. It's 1.2 million people work in it. There's something like 17,000 companies. It's it's impossible to own that. It's not up to a government body either to also develop tools for the industry. It's up to the industry to respond and deliver those tools based on needs. However, what they can do is establish the context, the framework. This is how the tool should function, or this is how we should, these are the requirements, and this is how we should be developing it. So a three-tiered approach, I think this is, you know, it's now a no-brainer. We need a modular architecture. It has to be scalable. It has to be, you know, have to be able to manipulate it. So, but the first thing is the common data framework. What's the language? What are the semantics? What's the, you know, ontologies, the processes, the practices, and so forth. So that's the baseline. That NRC can own. They can establish, here are the ontologies that you're going to use. Here's how you're going to structure your data. Of course, we have openBIM. We have a lot of open standards. So if you look in the report, we're just basically rehashing and mentioning and just jamming things that exist together. We're not going to go out and reinvent the wheel. That would be not very intelligent. We then have something that we can build upon that, which is the NRC digital construction platform. There are other government bodies. We were talking about the Department of National Defense. They need a secure framework. They need their own secure platform. However, they're going to use the same resources. The province of Quebec has a very aggressive roadmap. They'll want to build something too. So, or have people build it for them. That's the thing. And then we have modules. So the actual consumption layer. And so in this case, digital codes and e-permitting. So how do you consume and how do you automate the code compliance checking? So layered architecture. And if you look at it, if you expand it a bit, here we have the shared resource of the common data framework around the semantic resources, syntactic resources, conceptual data models, et cetera, et cetera. So really stuff, this is all laid out in the report, so I won't spend too much time. One thing that's important to keep in mind is the fact that when we're looking at specifications, material databases, and construction codes, we're always talking about the same thing. Concrete has to have a certain performance for the construction code, has to be specified and has to be tested. It's the same material, it's the same concrete, it has the same parameters, but they'll be used in different ways and across different layers. So this is really where the value and the value proposition is, to have NRC dictate, say, okay, here are the property sets, here are the ways that we're structuring the data, and then we can reuse in each of these resources. And one thing is that the way that why we're keeping them separate is that within the organization, the NMS, the CCMC, and the NMCC are three different entities within the organization. So we had to maintain and respect the fact that we weren't going to re-engineer the whole organization and had to work within these confines. So each sort of business line, if we want to talk about it, has their process to develop their resources, curate them, publish them. They get published to a web service. Again, not NRC that's going to deliver potential, and it could be many different web services, many different ways to look at it, but this is basically where we're going to connect into the platform. I'm a bit late on the kicker, and so here I don't have much time left, so I'm not going to go through this, but within the report, this is a way in which also, okay, you'll see, for those that are familiar, if you did the ISO 19650 game, you'll see the different states of information, but there's a continuous curating process. There is the platform, but the thing is, we also have to consider that organizations are working within their own ecosystems. They're working within their own platforms. They're going to want to exchange elements. So for the National Master Specification, well, an architecture firm might have their own specification based off the NMS, but they update and they keep it, and they want to keep that synchronized. So we have to figure out a way to be able to curate and push data, push updates to different professionals within their ecosystem while maintaining versioning and so forth. We have that for the NMS, CCMC. The important here is around the manufacturer. They're the ones that are publishing the data. There's a discussion right now on digital product passports. This is aligned with that discussion. There's efforts in Canada to put that forward. So again, submission, trying to create the network, the links. Third one is around the NMCC, and this is where it becomes a doozy. Municipalities have their own platforms. Other government agencies, for instance, in Quebec, la Régie du Bâtiment du Québec, they own the building code, but they're synchronized with the National Master Construction Code. So therefore, we need to be able to keep those synchronized. We're basing ourselves as much as possible on openBIM principles, using, you'll see, for instance, OpenCD principles, BCF as to communicate changes, track changes, looking at IDS and so forth to actually instantiate, implement these solutions and so forth. So a lot more detail. We provided also a roadmap. This is a now 6-year roadmap. As you can see, a lot of work to do. As you see, 3 streams, basically digitalizing the resources. That means digitalizing content, digitalizing the platform, or putting the platform together. And then the biggest component is delivering the platform, making people aware from it. Project governance, project management, stakeholder engagement. These are the people that are going to be actually using this tool. So that's a big component. And if you want to we've tried to map out a full view, and you can sort of see, well, it becomes quite complicated. The issue here, or the biggest concern here, is to make sure things talk to each other, and that comes back to this common data framework. So I'll invite Farzad to come back and maybe talk to the next steps from NRC's perspective. And thank you.
Thank you, Erik. The next steps, actually, this is something that we are thinking on, like the baby steps that we need to take, in terms of developing this area, like some items, this piece of puzzle, these modules together. So we have been more involved in that, like as I mentioned, in the environmental impact assessment part, LCA part, openBIM LCA application thing. This is one example that we are working on. openBIM GIS that Erik talked this morning is also like part of this item. But what is happening in the next step is we are kind of like announcing the RFP request for proposal from everyone who is actively into this code compliancy checks and the permitting processes to kind of like to work with us. We don't want to reinvent the wheel, as Erik mentioned. We are not software developers, and we are just trying to build such platform to be used by industry finally in Canada. So the first step is that to make sure what's the status of our current codes, our national building code, our energy code, and our fire safety code. Even in the national building code, we are starting with the part 9 of the code, which is more into the residentials and housing industry, because the affordable housing is turning to be one of the key items in Canadian construction industry. So we want to understand, like deep dive into our codes to see how our current rule sets are more compatible with the BIM specific solution and adopting with the openBIM standards. Then like how this code compliancy practices through the applications will look like, how we can use the emerging technologies like AI in terms of communicating with the with machine, asking questions about like what is going on in the rule sets in the code for that specific example, and how to communicate with the model in the BIM and do the code compliancy checks, and how to act how this application acts as a decision support system for the evaluator in terms of issuing the permits, either for new construction activities or for retrofitting processes, which is one of also like a key aspects in in our program in terms of decarbonization and productivity. So these are some activities. The RFP is coming hopefully by next month in April, and we are ready to collaborate with international entities, with Canadian specific construction industry, and we have different type of programs involving the academia and also industry entities to work with us. And this is one item, and as Erik mentioned, like this platform will stay until 2029, and we are going to also like act in terms of modernizing our IT platform. It's around like a $90 million also investment of the government in terms of modernizing the IT facilities to keep this type of digital construction platform up and running, and our like national model code and CCMC and NMS act and be active into this digital construction platform. Thank you so much, and I hand it over to the other speaker.
Thank you, Erik. Thank you, Farzad. Okay. Next, we are having a subtrack of technology innovation, artificial intelligence, and digital track. I believe that this is redefining how we build and operate, and also streamlining a lot of our workflows, enhancing decision making as well. Dell Technologies, which is at the forefront of this evolution, is actually enabling the organization to harness this power of AI and digital connectivity. Today, we have the honor of Ken Flannigan, Director of Industry Alliances and Solution at Dell Technology, who will share his insights into this particular topic itself. Ken?
All right, thank you. Very, very happy to be here. I think it can be somewhat confusing why Dell Technologies is here, but just as a show of hands, who has Dell Technologies in their office today? All right, the rest of you can leave. No, of course, I don't mean that, but it may surprise you that Dell hires people with my background. I'm actually been with Dell for 3.5 years, and my background is in industry. I started my career in architecture, early Revit guy, got involved with a reseller, did scanning, laser scanning with Leica HDS. So did elevators and escalators for a number of years with the Finnish company Kone, and 3.5 years with Dell, leading industry alliances and solutions for building, product design, and geospatial. So we're going to talk about technology innovation, the digital thread, which is one of my favorite terms. We hear it a lot right now, especially on the manufacturing side, and artificial intelligence, AI, because everyone's talking about AI. We'll have some practical examples of that. So we are not salespeople. My colleague here, Richard Lee, is also joining us from Dell China. Richard, say hi to everybody. But our purpose here is to build alliances with industry partners. We want to educate about things that you may not be interested in today. We want to make you interested in them, okay? All of the technology that you guys are using are underpinned by our systems, or maybe other systems, but definitely the foundation of what we're going to present today applies to every single one of you. So we'll start with AI and start with a very, very broad question around the biggest opportunity. This very high level concept, biggest opportunity for AI. We see a lot of chatbots. We see a lot of generative stuff. We see a lot of creative ideation tools, some playground type of tools. But I would challenge you today that the actual biggest opportunity in AI for this industry, and really maybe for all of engineering as a whole, is the concept of taking unstructured or semi-structured data and making it and turning it into structured data. And so what does that mean for the industry? Well, what's unstructured data? It's not just BIM. It's not just BIM. In fact, I think the best things that are going to happen in AI right now are not going to be AI enhancing BIM as much as it is allowing us to use and structure and query the data that is all throughout our organizations. Even things like emails. One of the most compelling AI stories I've heard actually came from Thornton Tomasetti, a large structural engineering firm. And they actually took a retiring metallurgist's email string or emails from 30 years of work as he retired and turned it into a digital assistant that can be queried in perpetuity so he could retire in peace. That's a little scary because when well, at least in the US, when we sign employment documentation, that's all their property at that point. So we really could all be turned into digital chatbots with all of our knowledge codified in that way. It's kind of an interesting concept. But what we're talking about here, and what I think is interesting for this group, is when we take unstructured or semi-structured data like this, and we turn it into an information model. Information model does not have to be 3D. It can just be pure data. But when we have a queryable information model from this unstructured data, we can start to interact with it. We can start to gain insights from it. And that is the path to agentic AI. Agentic AI, if you don't know, most of what we do today is not agentic AI. It is feature-based AI. We do one thing at a time. We ask it something. It's a chatbot. It's text to speech. But agentic AI is when AI starts to make decisions outside of our control. Now, we're not going to show any examples of agentic AI today. We're going to talk about some actual practical examples of some unstructured data being made into structured data that is then more useful. Now, I have one example. It's actually an example from Hexagon. Our partners at Hexagon put a video together for us that we'll watch. But this is not just singular to Hexagon, right? This actually is something that the Esri folks were nice enough to show me is happening in their technology as well. Their Geo AI tools, really amazingly awesome, taking aerial photography and really automating a lot through these computer vision AI features. But let's start looking at for those of you that have worked with point clouds, everybody pretty much worked with point clouds? Show of hands real quick. How easy are they to work with? They're not easy at all to work with, right? So in this case, they're doing object identification and classification based on pre-trained models. So then all of a sudden, this very unstructured point cloud turns into a very structured, separatable, much more easy to manage, much more understandable example of an AI feature. Now, this feature, much like some of the Esri features, actually happen locally. I will challenge you, anytime someone talks about an AI feature, ask them where that compute is happening. And if they don't have a clear answer, that is a problem. Where AI happens, where the compute happens, matters, right? It matters for privacy, matters for security, it matters to our clients. And there are some real reasons to run your AI features locally, right? For those reasons. There's other reasons like data proximity, right? Where do I need this inferencing to happen? Am I in the field when it needs to happen? What about data size? Am I realistically going to take the data that I'm going to use for this purpose and put it into the cloud? How much time is that going to take? I'll also say that most of your users have hardware that can do this today. If you have an NVIDIA RTX GPU, you have a very, very powerful AI compute platform, hopefully on a Dell machine. So when you have that, I want you to open your minds up a little bit. That is more than a rendering tool. That is a parallel processing unit that you can start to enable these AI features without fear for trust, without fear for where the data is going. Am I training somebody else's model? It's happening all on your workstation. And most of the time with hardware you already have, that you've already invested in. Our partners at Hexagon in the US put this together for us. Very grateful for that. Maybe we'll get Esri to do the next one. How about it, guys? Next example is RAG. Everyone's heard of RAG? RAG, Retrieval Augmented Generation. And this is a tool that if you have an RTX-enabled GPU, you can do this directly on your machine. So there's going to be some audio here, and hopefully the audio works. And they'll walk you through what this Chat RTX tool will allow you to do with all the safety and security that happens desk side on your machine.
AI technology continues to evolve rapidly, enabling large language models to run locally on your desktop or mobile workstation. Let's take a closer look at LLM technology and how it can be deployed in your business. This is the NVIDIA Chat RTX demo software that can run LLMs on RTX-enabled systems. You can select from a number of supported LLM models, and here we selected the Llama 2 13B model. Once it's loaded, we can interact with the model. But before we go any further, it's important to understand the relationship between LLMs and GPU memory. We have a Mistral 7B model loaded by Chat RTX. Using our Windows System Performance Monitor tool, we can see that the model has consumed 7 gigabytes of GPU memory. If we load the Llama 2 13B LLM model, we can see it consumes 9.4 gigabytes of GPU memory. So it's important to configure your system with enough GPU memory to support the LLM model you want to use. Remember, it will take a little bit more GPU memory when you're using the model, so we need to take that into consideration when selecting a GPU. Now we're ready to use our large language model. Let's ask our Llama 2 13B model, who's Ada Lovelace? We get a nice response about this famous mathematician who lived in the 1800s. If we ask the same question to the Gemma 7B model, we get a much shorter response. Different LLM models can respond differently to the same prompt. There are limitations to LLM models. You may have heard the term hallucination with respect to AI models. Let's look at some examples. We start by asking our model, which team won the Super Bowl in 2024? The answer is wrong, as the Llama model was released in 2023 doesn't know about anything that's happened in 2024. Let's try another question. This time we'll ask how many tensor cores are included with the NVIDIA RTX 6000 Ada generation GPU. As you can see, again, a wrong answer. Even though the GPU was released after the model's training, it responded with incorrect information instead of just saying it doesn't know. These examples illustrate why it's important to validate pre-trained models before widely deploying them. So is there anything we can do to help LLM models improve their accuracy? Retrieval Augmented Generation, commonly referred to as RAG, is a technique we can use to improve our pre-trained LLM model results and accuracy. So what is Retrieval Augmented Generation? Let's take a look at an example. If we use a pre-trained model and ask it the question, what was the name of that movie Chris emailed me about last year? The model can't answer the question about email, specifically my email, as my email was not part of the original model training. But we can provide additional information to the model. In this example, I want to provide information for my emails for the past year. If we take my email data and process it so we can store it in a data library, such as a database optimized for quick searching, we can then use my original prompt to search the data library for any information relative to my query and provide that data to the model. It can then use that information to generate a more accurate response. In this case, we're able to provide information from my email to help the model give the correct response. This is Retrieval Augmented Generation, providing additional local data to a pre-trained model to expand that model's capabilities beyond its original training. Now let's try this using our Chat RTX application. Here we provide additional data to our LLM queries. In this example, product data sheets from our NVIDIA RTX professional GPUs. Now when we ask our question how many tensor cores are included with the RTX 6000, we get the correct results. We can even ask more detailed questions. All the information is provided in our product data sheets, so we get complete, accurate results. And remember our sports question? Which team won the Super Bowl in 2024? Providing a 2024 sports roundup file to the Llama 2 model enables the model to provide the answer this time, the Kansas City Chiefs. So what have we learned? First, that AI models only know what they've been trained to know. Information that postdates the original training or is not included in their original training data set is not available to the model. Secondly, AI models can give wrong answers. If the information is not available, models can simply respond that they don't know the answer, or they could hallucinate and provide the wrong answer. And finally, retrieval augmented generation can provide new local data to pre-trained AI models. By providing new information as part of the original query, the model can use this additional data to provide more accurate responses to questions that reference data that was not part of the original LLM model training. The NVIDIA Chat RTX chatbot was used in this video. To learn more, visit the Chat RTX webpage.
As of right now, this is still a free tool. So if you want to tinker with this and you have an RTX NVIDIA GPU, really encourage you to do so. We have business leaders that actually load, because it's on their local machine, they actually load it on their C drive. They load financial reports from customers that they're about to visit and ask to summarize, top priorities. And so it's really kind of a secret weapon that you can use in your machine without fear for sharing any sort of data that happens in the cloud or anywhere else. You're not training anybody else's model. So those are the two kind of very early on, unstructured to structured data examples that I wanted to show. I do want to talk about the digital thread. Digital thread, something I ran into. The term, the red thread, was something I ran into in Sweden when I was working for Kone, a Finnish elevator company. And I certainly heard a lot about it recently at the PTC user conference and the Dassault 3D Experience World. And I wanted just to compare their experiences, because as much as we say that manufacturing is so much more productive than us, they struggle with the exact same things that we struggle with. They polled the audience at the PTC conference, and it was shocking that the majority of these folks that were, you look at the exhibit hall and it's all digital thread and automated feedback loops and all this real futuristic, amazing things. The reality is 95% of organizations are still just trying to manage documents. And that's a real challenge. So if we think about AI and the unstructured nature or semi-structured data of models and documents, there's a real opportunity here in the short term to make that an information model that in the future will turn into an agentic AI, which is really what we're all aiming for. Not today, but definitely tomorrow. Okay, I do want to talk about some product stuff, and this is, I know, not in the wheelhouse of designers. When I was a designer, I didn't care what my computer was or what was inside it. I was going to push it to the limit until they got me a new one. And then I was going to push that one to the limit. So I do want to educate you a little bit about what's going on currently in your machines. Processing is not just happening in one location, right? We had GPU, right? We all kind of understand GPUs. We saw some examples of GPUs. CPUs are not going anywhere either, right? CPU is very fundamental to the modeling applications, everything that we do on a machine. But even the CPU itself now has multiple types of cores, performance cores, efficiency cores, also has an embedded neural processing unit, an NPU. So if you have a newer version of an Intel processor on a Dell system, you have an onboard neural processing unit, a low power, low latency parallel processing unit. And today that takes care of things like background blur in Teams meetings and things like that. But what we're seeing, you look at a machine, you think, well, it's all just kind of happening inside. Compute is shifting inside that machine, and what machines you spec will matter to what you're going to be able to do with it now in the next, 3 or so years, whatever your renewal cycle is. And finally, I'll end with this. Dell is going through a very large rebrand right now. We are going from 11 sub-brands like Precision and Latitude and Inspiron and all these. Now we're down to 3 plus Alienware. Alienware is not going anywhere for our gaming customers. But the machines that engineers and professionals use today, those would be Dell Precision machines. But very shortly, they will all be transitioning to Dell Pro Max. There will be Dell for consumer products, Dell Pro for managed IT environments, and Dell Pro Max for discrete GPU, high-powered CPU, and workstation class performance. So these are products, some of the feature sets and use cases of each product. And these workstations, these performance PCs, they're for the people that create these models. They're for the people that do specialist type of workflows, whether that's simulation or reality capture or visualization. And they're also for collaborators, right? The project managers, engineering managers that need to interact with this data. So if you hadn't heard about Dell Pro Max, we still have our larger, most scalable towers that will continue on till their end of life as precision products. But I did want to take the chance to make you guys aware of this. I have one slide that I'm going to skip over real quick because we're pretty much out of time about some of the innovations going on in each of these. But I'll finish here. We have some QR codes. We have a info sheet on Dell Pro Max, a little 2-page document that has that grid that I just showed you. We have a link to Dell Pro Max product on Dell.com. And if you'd like to connect with me on LinkedIn, please do. There's a QR code for my LinkedIn profile. I do want to say we do have triple logos going on. That's because we always bring our friends along to the party. So we're here and supporting this, not just Dell, but we're also supporting with the help of NVIDIA and Intel. So with that, I'll turn it back over to the moderator.
Okay, how's everybody holding up? You guys and ladies want to stand up, stretch, and then sit down? You're coming to the last session. Okay, as the built environment is becoming increasingly data-driven, establishing clear goals, clear structured data requirements is crucial for efficiency, sustainability, and smart decision making. JTC has been at the forefront of this transformation in setting new standards in data requirements to support the future of buildings and infrastructure. So today, we have the privilege to have John Kiong, Director of Future of Buildings and Infrastructure Division at JTC, who will take us through the journey in how they define and implement their data requirements. Over to you, John.
Hi, good afternoon, everybody. In fact, before I start the session, Kevin has come over quietly telling me you're in between happy hour and the session. So without much further ado, let me just quickly share with everyone our journey in terms of our model content requirement. For those of you who might not be aware who JTC is, actually JTC Corporation is a statutory board under the Ministry of Trade and Industry. We are responsible for providing industrial space for industries in Singapore. So right from the master planning to the construction of our developments, and then to the facility management itself, and eventually rejuvenating the old estates. So our involvement in terms of the whole built environment starts from all the way from the planning, design, all the way through the construction, and eventually the facility management part. So I think, sorry, the clicker here. So I think, maybe I'll take this. Test 1, 2, 1, 2, yes. So for us, I think what is important is, I recall one thing about myself. I think many of you have you played this game before? No? It actually very often happens in team building sessions and all this, where you have your teammates queuing up in a row, everyone back facing, and then the first person will typically have a placard with a certain phrase or information or whatever, and then you're supposed to act out. And then the next person turn around, you act it out, and then pass on. And eventually, at the end, everyone always have a good laugh. Why? Because what is shared in the placard is totally different from the last person. What he said is actually totally different from what is on the placard, right? So that draws me into the scenario where data is very important. Data and accurate data. And especially in our context, that just now I shared, that our work spans across the entire value chain in terms of construction and maintenance to the end. So it is important for us to ensure that the data is passed on correctly and in a proper manner. So data is then the common currency for us. So it is important, with that in mind, we came out with what we call employer information requirement, EIR in short. So this one, so with this EIR, we look into information requirements, what data we need, and then we look at the management part, how we handle the data, and eventually how we want to implement it. So model content requirement actually looks at the data part, how we want to structure the data, and in a way to help create that true train in terms of the source of truth. So for us, as we start from the design planning, the data builds on as we go into the construction stage with from conceptual design, layering on to our detailed design, and eventually the tender documents itself, and our facility management colleagues taking over at the end. The information just gets on and on and on and get piled on. So for us, it's important that we structure this and clearly communicate this, our digital data requirements as a building owner across the entire chain. And we know data comprises both the geometry part and the non-geometry. In fact, quite a lot is non-geometry part. So it's also important then to capture this part of the data in a common and manner that stretches across the whole team. So we started to develop the model content requirement in 2021. Actually, that was the lull period where we all work from home. And then we started, spending some time working on this, due to COVID, sorry. So we started in 2021, where we start coming out with our version 1 of our MCR, where we standardize the data requirements across. And then in 2023, that's when we introduced and implemented the plenary platform that we placed our MCR onto, which has helped us to increase our efficiency. And eventually in 2024, we did a revamp of our MCR 2.0, aligning with the IFC SG. So, for us, it has helped us through with that data. We can now help us through from practical applications, across the BIM models, from progress track, from the design portion to at the front end, to progress tracking during construction itself, and eventually handing down the information to our facility management colleagues in terms of management. And also, actually, we do have our colleagues in managing the companies that lease the tenants itself, where then the data can also be passed on to them. Let's take a deeper dive into the MCR itself. So you can see how we layer on from concept design, where we progressively, add on additional data onto the model itself. So with that, just now I mentioned, last year with IFC SG coming on board, we did a little bit of revamp, because actually we do hear from the grounds, from our contractors, our consultants, and the whole team that actually is quite tedious, because our initial requirement was slightly different from the IFC SG. So we dive in, spend some time trying to align them, and then eventually coming up with just one, our MCR 2.0 version, which now it just enables one same platform for us in terms of our requirement. That has made the work much easier. So I'd like to share a little bit. Our MCR actually comprises quite a lot of data. right from about 2,000 over objects defined, spanning 27 categories and 300 over subcategories. So it is important, for us to manage all this data in a proper manner and comprehensive manner. That is where we came upon Plenary, and then we hosted our whole MCL on the Plenary platform itself, right? So it has allowed us, to cover, to plan out, like issues of what to model, what format, whom, where, how. All these are then now captured within the Plenary platform. Not only that, not only just capturing, it allows us now to check, to verify the MCL, because we can now automatically flag out any missing components within our requirements. So on this end, it helps us also in terms of our reporting. As you can see here, there's this tree color. So it can now quickly, what used to be a very tedious and monotonous exercise where our staff or colleague just go through details. Now we'll be able to quickly pick out what are the missing fields and then quickly dive into them. We can also now verify and track, because now everything is tracked, is compiled. Traceability is something now that we can do now, right? Quickly, in the past, before the Plenary, what we did was a highly manual. Just now I mentioned highly manual process that is inconsistent. We sometimes really miss out still, and lots of work to do for our colleagues. And then now with the Plenary platform now, it has standardized the whole checking process into one single environment, and then automated the whole compliance checking part. Of course, we do have challenges with that. Some of the key challenges that we do meet is the usual interoperability issues between the various systems, consistency or inconsistency of data itself between the various platforms, and even in the compliance checking part, we still do have error that we meet because of the large volume that go through. So I think with that, how we then, sorry, maybe the next slide. It's not working. How we then tackle this actually is on a few platforms. So for the MCR now, we carry out training for our contractor, our consultants, our own team, our own PM team. Now with that training, they are then familiar with the Plenary platform. We also built in processes like two-tier compliance checking, where we carry out periodic checkings through Plenary, and also came out with an execution plan, properly documenting it into a clearly mapping out what each stage, each of the stakeholders will need to do. And then eventually, now we even go down on site now with our IDD reviews, setting up processes where we now have also our IDD review meetings together with our contractors and consultants. So now, if you look at it, what is important for us is now we are able to then now standardize everything, right, with a clear governance platform, and eventually collaborating and working together with our various stakeholders to bring through our data from the front, all the way from the front end, planning design to our lease and tenant management. If you draw back to just now the analogy that I give about the game that we play, it now becomes as if everyone knows. Imagine your whole teammate, everyone knows how to do sign language. It's the same. Now the data can just pass on through, and then at the end of the day, it is accurate. So with that, I think I will pass my time now to Luke, our distributor, who will share with us a little bit on the, he'll show the model of the Plenary.
Right, thank you, John.
Yeah, sure.
Hi. So my name is Locke. I'm the implementation partner for Plenary. I've been on the project with JTC, very privileged to having worked with them for the last 3-4 years. And it's been a journey from MCR version 1 all the way to its current version. And when we started the project, the MCR version 1 was in Excel format, and it was almost 11,000 rows long, right? So it was quite a daunting task to actually get those requirements into Plannerly, but it wasn't that difficult anyway. So the reason why we used Plannerly in JTC was because we wanted to make sure that information is being checked on a consistent manner. So we do not, JTC did not want to have different projects checking information differently. If they do that, then there will be a lot of inconsistencies, and then there will be impact throughout the supply chain, especially down towards the tail end of the projects, right? With facility management, people will feel the impact of that. So all the requirements are defined using an intuitive interface, as you can see over here. Right, Suki. So from just this single interface, you can actually see when information needs to be implemented. Over the top, we have conceptual, prelim, detailed, as well as tender. And then you can also see all the elements that needs to be implemented. Now, what you see here is actually just a sample data. The actual one needs you to be security cleared. So we'll just show you a little bit of that, right? So, yeah, go ahead. So we'll just expand on each of the elements. And it's very important that the project team understands what needs to be modeled, right? And these definitions have been created through interactions with the stakeholders inside JTC. So it was easy for people to define it, and it's easy for the contractors, consultants to understand the requirements, right? Next one. All right, so we have some sample items here, and you can see the highlighted items. Those are actually who needs to model and when they need to model it. Yeah. So it's very easy to assign tasks to various teams, and the various teams can then filter out what tasks or what elements they need to model. Yeah. Okay. Right. And as we come to here, as you can see, each element has multiple rows of parameters, right? And all these parameters needs to be populated by the consultants, contractors at various stages of the project. So it's very clear, it's very intuitive interface, right? Next. Okay, so next we'll move to the verify module. So like I mentioned just now, how do we actually check information regularly on a consistent manner? All the project teams then upload their models on a regular basis, and it can be as regular as once a week. Some projects upload it twice a week, right? And the minute it goes into Plannerly, it automatically checks each element. And as you can see at the top, there are two colored circles up there, and that gives us immediately the percentage compliance of the model, right? For this version of the model. So, right, and the BIM manager or BIM coordinator can zoom into the model itself to see which element complies or don't complies to the information requirement. Right. Okay. Okay. So as John mentioned just now, there is 3 colors, red, green, and yellow. So it's very intuitive for any party in the project team to actually check it. So you don't need to have dedicated BIM managers trained in BIM. You can have quality managers of different backgrounds to actually do this checking, right? And at the top right, you can see the different versions. So I just showed you version 4 as an example. So now we'll move on to the next version. Click. And immediately it will then show you the percentage compliance across all the elements, right? So in this sense, you can actually see the progress of the model, how far and how fast the information is being populated, and how far and how fast it complies to it. So project teams do not have to wait till the last minute of handover to be able to view the information, right? This is a Kanban board workflow management, and where project teams actually use to be able to update their managers, supervisors, as to when the model is ready for checking, right? So it's very difficult for the project team to actually just send the whole model to BIM coordinator to check. So they'll just send off partial models and just say, okay, the doors are ready for you to check. So go ahead and check the doors. The others are still work in progress, right? So it's very intuitive to just pass it on to the next party to do the checking. And once all of that is verified, there is a simple dashboard to identify, to report on the total progress of the project, right? So with that, I think, yep, that's the end of the presentation as well as the demo. So I'll just pass it back to the moderator. Thank you very much.
Thank you. Okay, as we wrap up today's session, we have explored how digital transformation, data integration, technology, innovation, AI especially, shaping the future of our built environment. So our speakers have actually provided invaluable insights into the evolving landscape of our environment and our infrastructure as well. So with this, let's give a huge thank you and a round of applause to all our speakers that's here. Thank you very much, and I look forward in meeting you all for the next year event as well. Thank you very much.